To simplify a complex fraction, I'm going to multiply each individual fraction within this complex fraction by the least common denominator. One thing that I would do in this first example is I would turn this into 4 over 1 and 3 over 1, just to remind myself that 3 and 4 are the numerators of those individual fractions. That'll be helpful for when I multiply each numerator by the LCD, so I remember what I'm actually multiplying. So let's go ahead and look at all 4 of those individual fractions and build the least common denominator the same way we've done in the past. So I see that there's x's and 1's. The LCD then is simply going to be just x. I don't need those 1's, although I could say it's 1x. What I'm going to do differently than what I've done in the past with my LCD, though, is I'm not going to multiply the top and bottom to try to turn this into the least common denominator. Instead, I'm only going to multiply the numerators, each individual numerator of this problem, times its least common denominator. This will have the effect of canceling out the fractions within the fraction. If it helps, you can write those as x over 1 to remind yourself, again, you're just multiplying the tops of those by the least common denominator. Okay, watch what effect this will have. I want you to spotlight the problem and just look at part of it at a time. So let's just look at this piece of the problem right there. Since I'm multiplying and I have the same thing in the top and the bottom, those will cross out, cancel out, and leave behind just a 2. In other words, I've eliminated the fraction. This next piece, if I spotlight and look like right here, nothing cancels out. There's nothing the same top and the bottom, or nothing the same in the top and bottom, but that's okay. That 4 wasn't even a fraction to start with. I just made it look like a fraction so it was easier to multiply. So that piece just becomes a 4x. Let's move along, or move down to the bottom of this problem. Again, spotlighting and just looking right there. I see an x in the top and bottom, so those will get eliminated and leave behind just a 2. And finally, if I look, at this part of the problem right here, once again, nothing gets eliminated, but that's okay. 3 wasn't really a fraction to start with. I just made it look like a fraction. And so I end up with this. Now, a lot of people try to tell me, cross out the 2's, cross out the 2's. But remember, the plus and minus signs act as super glue, and so I cannot cross anything out until I factor it. I could factor the numerator if I tried. I could pull out a 2. And that would leave behind a 1 minus 2x. However, that will still not let me cancel anything out in the denominator, which can't be factored. So either of those answers are okay. It's worth trying to factor, though, because if you can factor and cancel, you have to factor and cancel. And we'll take a look at one more problem. Once again, I'm going to use the least common denominator to get rid of the fractions within the fraction. We're going to build the LCD the same way we've done in the past, so if that means you have to factor a denominator first, do it. None of these denominators can be factored, so I'll just simply need the individual pieces that I see. I'll need to take x plus 5, and I'll need to take x minus 3. Once again, I'm only going to multiply the numerators of these by that least common denominator. This will have the effect of canceling out the fractions within the fraction. One shortcut I like to do is I'm going to, again, spotlight and look just kind of at the top of this problem to start. I know what's going to happen if I multiply the numerator times that least common denominator. So if I want to save a little bit of writing, I know the x plus 5's would cancel out, but x minus 3 would be left behind. If that's confusing, if you don't like doing it that way, then do it the same way we've done in the previous example of the previous videos and write the whole thing out, but I'm just trying to save you a little bit of time. Down here, if I look at this part of the problem down here, I know that x minus 3 would cancel out, but that x plus 5 would be left behind. Notice I've included parentheses so I remember to distribute. And finally, I know down here, for this last piece of the problem, that x plus 5 would cross out, but x minus 3 would be left behind. So let's go ahead and distribute and see what I've got when I've eliminated the fractions within the fraction. So I'll distribute in the numerator. Up here I've got 3x minus 9. No longer do I have a fraction within the fraction. That's what I was going for. If you still have a fraction, then something's been messed up. Down here I'll distribute the 2. So I've got 2x plus 10. And finally, I've got this positive 1 to distribute. Be careful if you ever have a negative sign right there. We've talked about in class what to do in that case. So I'll distribute a 1, so I've got a positive x, and then a negative 3. My last step then is going to be to combine some like terms in the denominator. So I've got 3x minus 9, which I could factor. The denominator is going to become 3x plus 7. As we just talked about, I cannot cross those three x's out. They are not factors, that plus or minus sign acts as superglue and locks them in place. I can't cancel anything until I factor. So as I mentioned a moment ago, I could factor the numerator, but the denominator does not factor. And so in fact, nothing can be canceled out. So some people are going to ask me which is the right answer. Either one's fine. Neither one's considered more simplified than the other answer. However, it's always worth trying to factor, as I've mentioned.